Check 1, 2. Check 1, 2. Good evening. This is VK3EKH. Oh, kill that. VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Coming to you from the studios of VK3 CSJ in Narre Warren South. We're broadcasting on the prime frequency of 3541 kHz in the 80 metre amateur radio band, and also via the Melbourne television repeater VK3 RTV digital on the digital channel 1, and which can be also viewed on the BATC feed, the British Amateur Television Club video stream. In fact, I should just check that to see if that's in fact the case. Let me just check that, bring the mouse up there and check that. And we're also got a YouTube stream as well, so you'll find that if you type in VK3CSJ in the YouTube search engine, it will be delayed by about 20 seconds to what I'm referring to here directly on 80 metres, but still it is, if you don't have access to the VHF, the UHF repeater, ATV repeater, it's the next best thing, of course. Okay, I'm just trying to bring up my channel. Pardon me, because I accidentally deleted it. That's not it. Just refresh the page so I can see. Oh, it's YouTube. Yeah, I don't want YouTube. I know I'm there on YouTube. Oh, I've lost it. Oh, well, somebody tell me if the BATC feed's running. I can't be bothered looking for it right now. Okay. Now, this is going to be a short week, a short day, a short session, in fact. Just suffering a little bit from, I think it's hay fever. I don't usually have hay fever, but I've woken up today with dry, scratchy eyes and a nose that won't stop running, and just a general tiredness around the eyes. So I was that close to not coming up here tonight, but I thought not being here last Friday will probably be good. So I better show up tonight to update everybody on what's happening in the sky above, more or less. Yeah. Well, my nose might make it definitely a short night tonight. Anyway, it is the 1st of September. Welcome to September. Spring is now in the air, which I think we all know. Pardon me. So good evening to everybody. I trust everybody is better than I am at the moment, and all that sort of stuff. Okay, we have a few things tonight. Of course, it being the 1st of the month, we've got Sky Notes, Tanya Hill's Sky Notes to run through for the things that are happening this month. Another reason why I thought I'd better come up tonight to make it fairly current. And then just a couple of other things. So the Astronomical Society of Victoria was founded in 1922, has well over 1,600 members scattered about the countryside. Membership of the society is open to everybody with an interest in astronomy. The society's objectives the society's objectives are to encourage the study and practice of astronomy, and to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night. Meetings start at 8 p.m. at the Mollier Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located not too far from the Shrine of Remembrance. Parking is available, Burwood Avenue, Dallas Brooks Drive and surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV's magazine called Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a photoheliograph are also used or housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan in the telescope loan scheme, which members can try before they buy type concept. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two only with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is an 8.5 fully steerable radio telescope which members can access with involvement in the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same thing. Instrument making is only one of the number of common interest activities catered for within the Society. There's now 21 sections, I think. Other areas of interest the members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website at www.asv.org.au. That's www.asv.org.au. Notification of events are given in the Crux Extra bulletins, which is sent out via email to members every other week in between publications of Crux. Please note that ASV will conform to all government health directives. ASC events may be required to be cancelled, postponed or moved. The Secretary, you can write to the Secretary of the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001 if you wish to send a letter. Otherwise, email the ASC website, again at www.asv.org.au, is the place to go to for all information associated with the Society, and all the contact details there from the President to the various section directors are available on the website if you are interested in following up anything to do with the ASV and becoming a member. So this broadcast is on behalf of the Astronomical Society of Victoria. The call sign belongs to the Society and has since 1988. And we've been broadcasting since 1988 on Friday nights at 10 o'clock and continuing to do so. All right, so again, welcome to everybody tonight. To everybody viewing on the ATV repeater, g'day guys. We had a good time last Friday. The ATV QSO party went off like a hoot, and we had quite a few people rock on up on Friday night around the countryside, interstate, and Tasmania as well cropped up, and then Friday morning through to I think we went as far as 2 o'clock in the afternoon. Were crosses to the American ATV repeater group. There's a couple of those. So, it turned out to be another exciting event where all the anchors that were controlling everybody did their little jobs, and Peter VK3BFG and Ian VK3QL and Neil VK3BCU and Richard VK3VRS were doing their bit here in Melbourne to keep the system running smoothly. So it's a full-on job, especially when you're using the internet to cross between other stations. So it can get full-on. But it was a good time. Everything worked out fine. So another 12 months away, we'll do it all again. Anyway, enough of that. Okay, so we're here tonight and under a little bit of sufferance. Yes, forgot to mention, we also have an email address, so if you wish to send signal reports or whatever, VK3 ekh@gmail.com, you can send. I'm looking at the I was looking at the inbox. Where's that gone to? Oh, it's there, I see it. Let me just go and get this mouse working. That's the best thing I can do. The VCL factor is there. Okay, Wayne. So, all right. So, without any prompts. But there it is, vk3ekh@gmail.com. Send us an email from the remote places of the universe, so we'd appreciate it. And of course, we also have our chat window on Discord. So if you go to Discord, I think the site's discord.org is the something like that. Download Discord and look for ASV Radio, ASV chat room or something like that. Just type in that, you'll find the connection through. Okay. And having said that, I can see that we have Kim. Go up further. We have Daz, our resident shortwave listener and constructor and builder up there in Brisbane. We have Martin, VK7JAH in Launceston. We have ASV, oh, it's me. We have, down the list, we have Kim, VK5FUSE. G'day, Kim. Steve, VK3SPX. And Dave, VK3KDM, representing the Mount Burnett side of things. And Bill, VK3KHT. G'day, Bill, who's probably watching the TV as well. All right, now that I've woken up a little bit, let's go to Sky Notes and see what's happening in the sky for September morn. A lot of fuss about our moon this week, hasn't there? I mean, sure enough, it's been a little bit closer to the Earth, but boy, oh boy, does that not bring up a lot of fuss in the media. My goodness me. It's certainly looking good tonight. If I stick my head out the window here, it's bright as a 20-cent coin. Silver 20-cent coin. Okay, Sky Notes for September. I think I've got it here. Yes, that is right, correct. So, Tanya Hill, the resident astronomer at the Planetarium Science Works, says that the Scorpion's see thing heart, that's what she says. Scorpion's see thing heart, the surface of Antares revealed. The ESO's Very Large Telescope Interferometer, VLTI, at Cerro Paranal, Chile, has produced this most detailed image of the red supergiant star Antares, Alpha Scorpii, the heart of the Scorpion and the brightest star in that constellation. The VLTI's infrared telescopes gave excellent resolution and has given us the first such view of any star other than our Sun. Antares is a very different kind of star with the surface far more dynamic than our Sun. Now I do have an image there. It's not as clear as she's making out in the article. It's a bit blurry, but still you can see something. So there it is. For those watching the TV or the YouTube stream, hang in there, guys. You'll see it in 15 seconds' time. So that's the Very Large Telescope Interferometer result. There's another image just below this I'll bring up in a minute. From VLTI data, this first ever velocity map, and here I'll bring that up because now it's referring to this as a velocity map. So where are we? Go away. Okay, here's the velocity map. And what she's saying is that from VLTI data, the first ever velocity map was made of a star and reveals Antares tuning from large-scale turbulence within the star. Red represents gas moving away from us, and blue is where gas is moving towards us. The black ring represents the limb or edge of Antares, where data could not be obtained. Very interesting. And there's a kind of video here too, which I'll run. I don't know exactly what this is about, but there is a little video here that's associated with this article. It's a animated thing. It only goes for 30 seconds, but I think I don't think there's any sound to it. I hope there's not any sound. Let's just check that before I go on. Make sure that audio is off. Okay, let's run this. Oh, there is audio there, but I'll kill that. All right. So, and let's put it in a loop. All right. So what we're looking at now is she says that Antares has over 11 times the mass of our Sun and lies over 550 light years away. At its late stage of stellar evolution, it has expanded to 600 to 800 times the size of our Sun, with a tenuous outer layer of gas. While its surface temperature is about half that of the Sun, its surface area is vastly larger, and so it appears much brighter, radiating about 10,000 times as bright in visual wavelengths. However, its total output or luminosity across all wavelengths is perhaps 100,000 times that of the Sun, although that figure is not definite. So yeah, there's some sort of animated image there. It's kind of with an idea of making the resolution or the detail a little bit sharper. Interesting. That's not a real image though. It's just a computer-generated simulation, I think. Okay, moving on to the next part of this. Let me just bring me back to me. Okay, supernova event. Antares, continuing on a little bit about this. Antares is expected to ultimately become a supernova, leaving behind a residual neutron star, or perhaps a black hole. If human or other eyes on Earth witness the event, the supernova should be visible during even the daytime. Antares B. Antares has a smaller, fainter, very distant companion, Antares B, Alpha Scorpii B. In comparison to our Sun, it seems to be 7 times as massive, 3 times the surface temperature, and 5 times the size. After the supernova event, Antares B will have a different, very changed companion. To see Antares in Scorpius this month, look high in the west at an hour or so after sunset. Alrighty then. It's spring equinox again. Here in the southern hemisphere, we are about to experience spring equinox. This is when day and night are effectively the same length. This will be Saturday the 23rd and marks the end of winter and beginning of spring in the southern hemisphere, and the end of summer and the start of autumn in the northern hemisphere. At the equator, at an equinox, the noon sun sits directly overhead, and both hemispheres receive equal hours of daylight. Away from the equator, the sun path in the sky is midway between its summer high and long arc and its winter one, which is low and short. The main reason for the seasons lies in our planet's tilted axis of rotation, which is 23.5 degrees, with respect to its orbit around the Sun. At an equinox, neither hemisphere leans toward or away from the Sun. However, local day and night are not quite equal at equinoxes. Astronomical timings are based on how long the center point of the Sun's disk is above the horizon. A local day effectively starts when the leading edge or limb of the Sun broaches the eastern horizon and ends when its trailing edge or limb drops below the western horizon. There is also a terrestrial effect as well. The Earth's atmosphere refracts or bends light from the Sun, so that at sunrise we get the first glimpse of the Sun before it physically crosses the local horizon. The reverse occurs at sunset, when we see the sun for a few minutes after it has really sunk below the western horizon. So, for September, the Melbourne sunrise and sunset times. Today, the sun rose at 6:42 a.m. and set at 5:58 p.m. with a day length of 11.15 hours. Monday, the 11th, it'll be rising at 6:27 a.m. and setting at 6:06 p.m. On Thursday, the 21st of September, sun will be rising at 6:12 a.m., setting at 6:15 p.m., with the day being just over 12 hours. And by the end of the month, Saturday the 30th, the sun will rise at 5:58 a.m. and set at 6:23 p.m, with the day being 12 hours and 24 minutes. So those days are getting longer. Oh dear. Energy. Moon phases. Third quarter is on the 7th of September, Thursday. There's a new moon on Friday the 15th. There's a first quarter on Saturday the 23rd. And there's a full moon on Friday the 29th. The moon will be at lunar perigee, closest to the Earth, on Thursday the 28th at 359,911 kilometres, and then will be at apogee, furthest from the Earth, on Wednesday the 13th at 406,634 kilometres. Okay, what's happening with our planets in this solar system of ours? Mercury is not visible this month after having passed in front of the Sun. It is too close to our local star to be seen. Venus can be seen in September in the dawn sky about 2 hours before sunrise, from 4:30 a.m. early in the month, and a little earlier each morning. Mars cannot be seen this month as it passes behind the Sun from our point of view on Earth. After 4 months, it will reappear in mid-February in the east as an early morning planet. Jupiter is visible this month from 11:30 p.m. in the northeast early in month, and then a little earlier each night. It will move across the north before being lost in the early morning light by 6 a.m. Saturn is a beautiful planet to observe this month, rising in the east from 6:30 p.m. early in the month, and then a little earlier each evening. Its subtle yellow tinge should make it obvious all night as it moves across the north and then to the west before fading by 5 a.m. Meteors. While not a good time for meteors this month, the southern Pisces will peak from 11th to the 20th. They usually number only a few per hour and appear in the constellation of Pisces the fish, which rises in the northwest from midnight. The southern Pisces. Find out more about these space visitors at NASA's Asteroids, Comets and Meteors. That's a link that she's provided there. And as far as the stars and constellation go, they're not disappearing anywhere very soon. In the north, high in the north are Sagittarius, the Archer Centaur. Its bow and arrow forms the famous asterism the Teapot, the spout of which leads across the zenith to the curving tail of the nearby Scorpius. Lower in the north sits Aquila, the eagle, with Altair or Alpha Aquili, the 12th brightest star at night. And quite low in the north is Lyra, and its principal star Vega and Alpha Lyra, which is the 5th brightest star at night. In the east, turning your chairs towards the east, directly east this month, is just bumped the microphone, is a trio of ancient constellations. In the centre is Aquarius, the water bearer, while above is Capricornus, the goat. To its left sits Pisces Ostrinos, or the southern fish. I hate Latin. Containing its main star, and the 18th brightest star at night, is Fomalhaut, or the Alpha Pisces Ostrinos. In the south, if you turn your chair to the south, low in the southwest can easily be seen two of the brightest stars in the night sky, Alpha and Beta Centauri. You can't miss those. We all know where they are when you look up. These are the two brightest stars in the constellation of Centaurus the Centaur, with Alpha Centauri also known as Regal Centaurus, the foot of the Centaur. Together, these two stars are referred to as the pointers, as they lead directly to the unmistakable diamond shape of the crux, or the Southern Cross. Crux is the smallest of the traditional 88 constellations astronomers use, and is an easy feature of the night sky to observe, even in city surroundings. In the southeast is the 10th brightest star, Achernar, in the long constellation of Eridanus, the river that winds its way down to the horizon. Turning to the west, high in the west sits the curving tail, body and pincers of the scorpion. Pincers of the scorpion, Scorpius. Within its body you should see red giant star Antares, which will appear more orange than red in light polluted skies. In front of the scorpion's wide head and closer to the horizon sits Libra, the scales. You know, when it comes to looking for these constellations, I know I read them out here, and I kind of make reference to the east and looking at west and south and west. I don't know how many of you actually do that. To make it easy for yourself, we've all got mobile phones these days. If you download a star chart program like Stellarium, I think Stellarium is workable on mobile phones, but I've brought my mobile phone up here. I've recently installed a very nice little program that suits mobile phones. I see if I can bring it up and show you on the TV. But like I say, if you install these programs, they're really very, very good. And because they operate on GPS and exactly where you're located, these things work very well for telling you what's in the sky above, right above your head in real time. Star Tracker. Yeah, I've got an app here called Star Tracker, all one word, or Star Tracker. And I'll just put it up on the screen here for those watching TV. This is Star Tracker running right now, and geez, it's a bit hard to see where I'm looking. But as you can see on the YouTube channel, it's this camera. The mobile phone would be looking towards the west in the view there, and you can see exactly what constellations are up at the moment. And as I rotate the mobile phone, you can see how those constellations actually change position in relation to where the camera is pointing, and it's happening. It's updating so fast. There's no delay in it. The processing that's going on is just outstanding. I reckon that's a beautiful program. There's even a little bit of music that runs in the background, that kind of music. Isn't that cool? So, like I say, I can tell you what's up in the sky, like I do. But shut up, go away. But something like that, Star Tracker, is really, really worth it, and it makes looking at the sky at night even more interesting. Okay, thanks Tanya for your reports there. Anyway, is there any coffee left? Oh, there is. Okay, the International Space Station. Look, it's 10:30 already. You're tuned to ASV Radio, VK3 Echo Kilo Hotel. The International Space Station, at a distance of about 400 kilometres, completes an orbit every 90 minutes. 90 minutes. That's how some Americans pronounce it. They knock out the T for some reason. 90 minutes. 90 minutes. Every 90 minutes, and appears as a bright object that moves slowly across the night sky. There will be many visible passes this month over Melbourne and central Victoria, and here are two of the brightest and highest in elevation this month. On the morning of the 23rd of September, Saturday the 23rd, there's a passing at 4:22 a.m, starts at 4:22 a.m, and goes to 4:25 a.m, coming in from the east-southeast, overhead to the southeast. Then on the evening of Sunday the 3rd, that's this Sunday, just checking on that. So on evening Sunday the 3rd, there's a passing at 7:07 p.m. to 7:12 p.m. coming in from the southwest to the northeast. If the skies are clear. Now, heavensabove.com is a great place to go to for updates on what's going on overhead. So if you don't download star tracking app, you can go to heavensabove.com, and there you can find out anything that's going overhead. Satellites, iridium flares. I think iridium flares are still flaring. Anything that's in the sky, this Heavens Above has got all that prediction charts and tables and tells you what's going overhead and when to look out for it. On this day, on the 1st of September 1939, American J. Robert Oppenheimer, I haven't seen the film yet, and Hartland Snyder published the first paper that describes the gravitational contraction of a star, which later led to the modern concept of black holes. Yes, Oppenheimer was involved with that, so despite his involvement with the atomic bomb, he was quite the astrophysicist, and describes the gravitational contraction of a star, which later led to the modern concept of black holes. That was the 1st of September 1939. Such brilliant men around in those days. Also on the 1st of September 1859, and I think most of you have known this particular thing, on iPad, really, Kim? Oh, that's interesting. Sorry, I got distracted there for a second. On the 1st of September 1859 was the Carrington event, and that was the most powerful geomagnetic storm ever recorded, now understood as a coronal mass ejection from the sun that hit Earth's magnetosphere, inducing strong northern auroras almost to the equator, and telegraph interference in Europe and North America, with operators receiving electrical shocks. The poles were sparking and signals sent despite power cut off. Right. So yes, the Carrington event, 1859. Also on the 1st of September 1979, Pioneer 11 made the first flyby of Saturn, returning the first close-up images of the planet. It was the second probe to pass the asteroid belt and Jupiter and to reach the solar escape velocity. Last routine contact was on 30th September 1995, and the final data received was on November 1995. That's Pioneer 11. On the 5th of September 1977, Voyager 1 is launched to explore the outer solar system. After 42 years, it continues sending data and is the most distant probe at 21.8 billion kilometres, or 146 AU. It entered interstellar space in 2012, and its power supply may last until 2025. On the 8th of September 2004, Genesis USA probe crashes in Utah while returning samples of solar wind particles. Some collecting panels survived impact and were recovered, giving successful scientific results. Genesis, not the probe from Star Trek, which is the first thought I had. The 11th of September 1985, the International Cometary Explorer, or ICE, USA, became the first spacecraft to encounter a comet by flying through the dust tail of comet Giacobini-Zinner. Boy. On the 14th of September 1959, Luna 2 was the first craft to fly to and impact another body, in this case the moon. I don't think that's changed. It released sodium gas to allow visible tracking. Used radio for telemetry transmission and crashed into Mare Imbrium, the Sea of Rains. Whew. I've got an article on that tonight too, which I better hurry up on. On the 17th of 1976, that is the 17th of September 1976, NASA unveils its concept for a space transportation system, a rocket-launched and glider return orbiter known as the Space Shuttle. That was 1976. On the 17th of September 1857, birth of Konstantin Chulosky, a pioneering Russian, then Soviet teacher, whose theoretical work on aerodynamics and rocketry influenced all who followed. He advocated spaceflight and believed humans would colonize the galaxy in time. On the 18th of September 1977, Voyager 1 sends the first image of Earth and Moon together, taken from a distance of 11.6 million kilometres while it's on its way to Jupiter. On the 21st of September 1633, the Roman Catholic Inquisition begins its trial of Galileo for heresy in publishing and advocating a heliocentric or sun-centered solar system, contrary to the church doctrine, dogma and scripture, which only changed as late as 1973, I think was the year. They kept that whole concept that the sun was going around the earth in their church doctrine and dogma and scripture for until some time not too long ago they decided to update that scripture. I think that's the case. Got it wrong. On the 23rd of September 1846, Neptune, first predicted by Urbain Le Verrier, France, is discovered by Johann Gottfried Galle, Germany, with John Crouch Adams, easy to say that one, recognised for an independent discovery. That was Neptune, 1846. On the 27th, final date, on the 27th of September 1905, Albert Einstein published his paper containing the famous equation E equals mc2 squared. Energy equals mass multiplied by the speed of light squared, meaning that a small amount of matter is equivalent to or can be converted into a great deal of energy. Thank you, Tanya Hill, for your Sky Notes for this month. Much appreciated. I always look forward to reading those out as we start a new month. You're tuned to ASV Radio, VK3EKH, and Daz up in Brisbane is giving me a report that the signal on 3541 is fading up very strong and now in Brisbane at times. Good. Excuse me. All right, time. Okay. Well, we all knew that Russia's probe to the moon crashed. But India's had success. India is now in that group of countries that have reached the moon and landed and doing stuff. Good on them. India's lunar rover detects first elements ever found at Moon's south Pole. And I've got a picture here of the probe sitting on the surface of the moon, taken by the rover. There's a little rover that has gone out and taken a picture, and there it is. That's what the probe looks like sitting on the surface of the moon. That's resting at the South Pole. India only landed on the moon last week, but its Chandrayaan-3 mission has already made its first scientific observations of the lunar South Pole. By shooting lasers at the surface, the onboard rover has confirmed the presence of sulfur, the Indian Space Research Organisation has announced. It's the first rover to ever explore the region. The laser-induced breakdown spectroscopy (LIBS) instrument on board Chandrayaan-3 rover has made the first ever in situ measurements on the elemental composition of the lunar surface near the South Pole. These in situ measurements confirm the presence of sulfur in the regions unambiguously, sometimes that has not feasible by instruments on board the orbiters. And there's a little chemical spectrograph here too I've got. Where's that? There it is. Okay, this is what they've detected so far in the chart on the screen. Preliminary analysis also hints at the presence of aluminium, iron, calcium, chromium, and titanium. Further measurements have revealed the presence of magnesium, silicon, and oxygen, though investigation regarding the presence of hydrogen is underway. While China and Russia and the US have all landed on the moon, previous attempts by Russia and India to reach the South Pole have been unsuccessful. The South Pole is thought to be the most water-rich area of the moon, and the Chandrayaan-3 rover, known as Pragyan, will spend the next 2 weeks using its laser to hunt for signs of frozen water, as well as studying the atmosphere and figuring out the composition of the South Pole. Frozen water could be incredibly valuable if found on the lunar surface, seeing as it could one day be used to produce breathable oxygen for further lunar bases, and could also provide ingredients for rocket fuel that could help send missions to Mars. The name Pragyan, I think that's how you pronounce it, Pragyan, is derived from the Hindu word pragya, meaning the highest and purest form of wisdom, intelligence, and understanding. Magnificent. The small rover weighs only 57 pounds, 25.8 kilogram, and is roughly the size of a small German Shepherd. Oh, you're kidding. It's equivalent with the laser-based LIBS tool, but also an alpha particle beam. The LIBS is able to detect elements by firing intense lasers at the lunar surface and generating hot plasma. By studying the light from the plasma, researchers can identify the wavelengths of different particles in that particular chunk of the moon. We can't wait to see what else it finds over the next few weeks, the article says. So there's this probe, the rover actually, this is the rover it's actually referring to here at the moment. The rover is about the size of a small German Shepherd. Well, a small German Shepherd, I don't know, but there it is anyway. They have video of the rover coming off the main probe. It almost looks like it's in real time, but I couldn't get the video to play. It was difficult for the video to be brought into vMix for some reason. So I'm not sure why it wasn't going to work. You're tuned to ASV Radio VK3 EKH, coming to you from the studios of VK3 CSJ in Narre South. I think this is a relatively quick story. Marilyn Lily Lovell, wife of astronaut Jim Lovell, dies at 93. And I've got a picture of her and her family. Where are we? Back here. There she is. Okay, so in the article, the Wisconsin native was a member of the Astronaut Wives Club and is immortalised on the moon with a mountain in her name. On August 27, 2023, Marilyn Lily Lovell, wife of Captain James A. Lovell Jr., American astronaut in the Gemini and Apollo programs, died peacefully in Lake Forest, Illinois, surrounded by her husband and family. Marilyn Lovell, born July 11, 1930 in Milwaukee, Wisconsin, was the youngest of 5 children. She attended She attended junior high school in Milwaukee, where she would meet her future husband and partner for 71 years. Originally attending the Wisconsin State Teachers College at Milwaukee after high school, Marilyn later transferred to George Washington's University to be closer to Jim, as he attended the U.S. Naval Academy. The high school sweethearts married shortly after Jim Lovell's graduation in 1952. As an active member of the Astronaut Wives Club, Marilyn Lovell promoted her husband's NASA's career and provided support to other astronaut wives. And there's another picture here. Bring up, there she is. Okay. In this picture, Marilyn Lovell talks with Apollo 13 flight surgeon Charles Berry in a viewing area behind Mission Control on April 14, 1970, just hours before an onboard oxygen tank exploded and imperiled the mission. So, a tribute on the lunar surface. A triangular mountain on the moon was named Mount Marilyn by astronaut Lovell during the Apollo 8 mission. And here's this picture of this particular mountain range. The 4,600 foot tall or 1,400 meter tall peak sits between the dark lunar lava plains of Mare Tranquillitatis, Sea of Tranquility, and the Sea of Fertility. Astronaut Lovell first named the feature from lunar orbit as he mapped potential landing sites for the upcoming Apollo 11 mission. After scanning the Sea of Tranquility's coast, Jim Lovell spotted the mountain and its distinctive pyramid shape, which would be recognised to future crews. He quickly checked with his fellow crew members to see if anyone had spotted it before him. They answered in the negative. Then I found it. I am going to name it, Lovell said, and recounted in his 1994 book, Lost Moon, The Perilous Voyage of Apollo 13. He says, "What do you guys think of Mount Marilyn?" So that funny looking object in the middle there, not the command module, but that mountain at the top there is Lake Marilyn. If you've got a good telescope, you may be able to see it. Mount Marilyn served as an important landmark of the Apollo 11 astronauts as they descended to the surface, and the name appeared on many Apollo-era technical maps and reports for decades. It was an informal designation, but on July 26, 2017, the peak was officially recognised as Mount Marilyn by the International Astronomical Union. Marilyn is survived by her husband, her children Barbara Harrison, James Lovell III, Susan Lovell and Jeffrey Lovell, and 11 grandchildren and 7 great-grandchildren. There you go. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. At about 12 minutes to 11, the next thing I have here is, and I might skip that one. How long is it? It's actually not very long. I might just cover it. Have astronomers finally found a meteorite from outside the solar system? Researchers have pulled material from the sea floor that might be interstellar. The proof will lie in the testing. After an expedition that spent about 10 days scouring the ocean floor of Papua New Guinea with a magnetic sled, Harvard University astrophysicist Avi Loeb says he has collected more than 700 metallic spherules. I think that's how you pronounce it. Spherules. Spherules. That are now undergoing detailed examination to his lab at Harvard, as well as at least 2 other independent labs that he asked to help out. Loeb believes that many of these spherules, each less than a millimetre across, about the size of a pinhead, came from the first ever interstellar meteorite to have been detected striking the Earth. He was able to pinpoint its entry location in the South Pacific through a combination of Department of Defense tracking data and seismic readings from 2 nearby locations. It's the most exciting week of my scientific career, Loeb told Astronomy in a shipboard Zoom interview during the expedition. In a follow-up interview with his return to Cambridge, he said that the number of spherules identified in the collected material was continued to rise day by day. And to give you an idea of what we're referring to, I've got a picture here of an example of this. So, going quickly back to the article. The image up on the screen right now. This is a slice of a meteorite found in Western Australia and shows spherules embedded in the rock. So this is what we're talking about. I don't know exactly how big the rock is. That doesn't really say how big it is, but all those little dots, they're referred to as spherules. Excuse me. So this is what's getting this chap all in an exciting thing to do. That's I haven't gone right through the whole article, but that's on astronomy.com under the news tab, I think. Have astronomers finally found a meteorite from outside the solar system? Okay, now this is interesting footage. They've found the location where the Russian Luna 25 lander crashed into the lunar surface. I've got a GIF image here that's going from before and after. So I'll just play that briefly. There it is. So what you're seeing on YouTube right now and all the TV repeater is a before and after. Before and after. Luna 25 slammed into the moon on August 19 during a manoeuvre designed to set up its touchdown. The final resting place of Russia's failed Luna 25 lunar lander has apparently been found. Luna 25's Russia's first moon probe in 47 years smashed into the lunar surface on August 19 during a manoeuvre designed to set its touchdown try a few days later. The crash blasted out a crater with NASA's Sharp-Eyed Lunar Reconnaissance Orbiter, LRO, likely found last week. So there it is. The GIF image alternates between the Lunar Reconnaissance Orbiter views from June 27, 2020 and August 24, 2023. So there's definitely something that's impacted the surface. There's no doubt about that. Okay, there's a bit more to that article, but I think that's all we need to see at this stage. And James Webb's telescope. Let me bring this up. The James Webb Space Telescope has a stunning view of a supernova's expanding remains. This is published 8 hours ago. This supernova, the brightest in the past 420 years, signalled the explosive depth of a supergiant star in the Large Magellanic Cloud. The remains of the star that exploded 36 years ago have fallen under the gaze of the James Webb Space Telescope, and this observatory's near-infrared camera captured the expanding shell debris in unprecedented resolution, revealing brand new details about the burgeoning supernova remnant. And there is a bit more, another image here that makes it a bit more detailed with some text on it. The closest observed supernova since Kepler's supernova lit up Milky Way in 1604, this star explosion was first identified in 1987 and is aptly known as supernova 1987A. It sits about 1,000 168,000 light years away from Earth in the southern Magellanic Cloud, in the Large Magellanic Cloud, and represents the destruction of a blue supergiant star called Sandulic 69202. Before it exploded, the star was thought to hold a mass of about 20 times that of our Sun. So bright was this supernova, in fact, that it was visible to the naked eye in the southern hemisphere, and astronomers have been tracking it expanding debris ever since. Now, the JWST has been brought to bear on the supernova's remnants in a study led by Mikhail Masura of the Cardiff University in the UK, resulting in this spectacular image of a dead star's aftermath. And I'll leave that there. So it's a pretty intense looking image, that one. When I get my telescope set up, I'm going to train it to it and see what I can see. Probably won't see that though. Alright, you're tuned to ASV Radio VK3 Echo Kilo Hotel. This is a short article too, and I'll bring up, there's a picture associated with this too. Okay, this is a star-studded stellar nursery shines in new Hubble telescope photo, and this is published just 1 hour ago. Hubble has photographed a bright star nursery studded with dazzling infant stars. The Hubble Space Telescope has photographed a bright stellar nursery studded with dazzling infant stars. Taken using Hubble's Wide Field Camera 3 instrument, the image captures a massive protostar called OH339.88-1.26, lurking behind star-forming clouds of dust and gas. OH339.88 lies an estimated 8,900 light years from Earth in the constellation of Ara, Ara. During the photostellar phase, stars are still in the process of gathering mass and their parent molecular clouds. Despite its young age, OH339.88 is estimated to be about 20 times the mass of our Sun, according to a statement from the European Space Agency. Just reading ahead here. A maser, which is short for microwave amplification by stimulated emission of radiation, is a naturally occurring source of stimulated spectral line emission, or laser that produces coherent light at microwave wavelengths. This type of emission has been observed in molecular clouds, comets, planetary atmospheres like that of the North Pole of Jupiter, and stellar atmospheres. The recent views of OH339.88 were collected as part of an initiative to study the hearts of regions where massive stars are born to better understand the nature and formation of protostars. So yes, there it is. There's a little bit more to that, but that'll do. So it's an amazing picture. It really is quite stunning when you've got a telescope outside the Earth's atmosphere, what can be seen. Okay, next we're coming up to the hour, so I just want to try and finish up if I can. Oh yeah, yes, okay. Just a plug for astrophys.com. Oh, sorry, losing the voice I think already. Where's my slide? Looking for my slide. There it is. Okay, now you've heard podcasts from Brendan O'Brien on our program over the years, many years. Just a quick plug for astrophys.com. If you've got nothing better to do, you can go to astrophys.com and have a listen to any 177 episodes of interviews he's recorded with scientists, astronomers, and the like. So astrophys.com. Thanks, Brendan. And also a plug for the MBO. If you live up in the hills, it's a 20-minute drive from here. There's a wonderful observatory. It used to belong to the Monash University, but there's a wonderful observatory up there at Mount Burnett in the hills. Mount Burnett Observatory, MBO, and every Friday night they have various activities going on. If the sky is clear, telescopes come out to view the sky. If you wish to get involved or find out about Mount Burnett Observatory, just visit the website. Just type in Mount Burnett Observatory, as in right Mount, M-O-U-N-T, Mount Burnett Observatory, to find the website. And if you have Facebook, they are also on Facebook. They're doing great guns. In fact, I saw them on Channel 31 about a week ago. The community TV station, Channel 31, had a few hours dedicated to some interviews and talks with Mount Burnett people, which I thought was interesting. All right, let's go to spaceweather.com. There's no report from Tamitha Scove, I'm sorry to say. I know a number of you enjoy listening to Tamitha, but her last report was over a week ago, so she hasn't updated, so there's nothing for tonight at the moment. Let's get off the slide. Go back to vMix. Oh, where is my mouse? There it is. Mumble. The disk of the sun right now looks like that. You better be looking at YouTube or RTV. Anyway, there are 5. There are 5 active sunspot regions on the disk of the sun as we speak, and there they are. The solar wind is currently at 403.5 kilometers a second. It is blowing a gale. A density of 7.94 protons per cubic centimeter. You could almost count them. The sunspot number is currently 77, and the radio sun, measured at a wavelength of 10.7 centimeters, the radio flux is 140 solar flux units. The K index, the planetary K index, is currently 2.67, which is considered quiet. The 24-hour max is 3, also considered quiet. The southern auroral glow over at the Antarctica at the moment looks like this. So there's quite a bit of auroral activity going on over the South Pole. If you're in the southern part of New Zealand at the moment, you'd probably see a little bit of glow in the southern sky. It's probably the same for Tasmania. But that's the auroral glow currently. And there's also a GIF image here too of a solar flare launching, and the report here is that a long duration solar flare on September 1 began with a solar flare. That's the movie you're seeing now. Peaking at 0100 UT, the M1 class explosion formed sunspot AR3413 and lasted for hours, long enough to lift a CME out of the sun's atmosphere. Fresh data from the SOHO coronagraphs will tell us if there is an Earth-directed component. Meanwhile, another CME is already en route. Keep reading. The Earth-directed explosion, a magnetic filament on the sun, erupted August 30, opening up a canyon of fire in the sun's northern hemisphere. A CME billowed out into space and shown here in a movie from the Solar Heliospheric Observatory, SOHO, which you can see playing out on the screen and on YouTube right now. The NOAA predicts that the CME will hit Earth on September the 3rd, likely causing a G1 class geomagnetic storm in high altitude. Skywatchers should be alert for auroras. I would suspect that Tamitha will be putting out a report fairly soon, actually. Okay, right down the list. As far as near-Earth asteroids go, as of the 1st of September 2023, there were 2,349 potentially hazardous asteroids. That's today's spaceweather.com, which is a very interesting page to keep checking on a regular basis. And one final thing to finish off, a prologue, an epilogue of sorts. This, where's my article? Oh, yeah. Where is the edge of the universe? Where is it? Published August 31. When Galileo Galilei pointed his first telescope to the heavens in 1610, he discovered congeries of innumerable stars hidden in a band of light called the Milky Way. Our cosmos grew exponentially that day, and roughly 3 centuries later, the cosmic bounds exploded once again when astronomers built telescopes big enough to show the Milky Way is just one of many island universes. Soon they learned the universe was expanding too, with galaxies retreating from each other at ever-accelerating speeds. Since then, ever larger telescopes have shown the observable universe spans an incomprehensible 92 billion light years across and contains perhaps 2 trillion galaxies, and yet astronomers are still left wondering how much more universe is out there beyond what they observe. The universe has always been slightly larger than what we can see, says Virginia Trimble of the University of California, an astronomer and expert in the field's history. Building bigger telescopes won't help extend the cosmic anymore. Telescopes only observe the observable. You can't see back in time further than the edge of the universe, or the age of the universe, explains Nobel Prize-winning cosmologist John Mather of NASA's Goddard Space Flight Center, who's also chief scientist for the James Webb Space Telescope. So we are totally limited. We've already seen as far as you could possibly imagine. At the edge, we see the leftover glow from the Big Bang, so-called cosmic microwave background radiation, or the CMB. But this isn't some magical edge of the universe. Our cosmos keeps going. We just may never know how far. In recent decades, cosmologists have tried to solve this mystery by first determining the universe's shape, like the ancient Greek mathematician Eratosthenes calculating Earth's size using simple trigonometry. In theory, our universe can have one of 3 possible shapes, each one independent of the curvature of space itself: saddle-shaped, negative curvature; spherical, positive curvature; or flat, no curvature. Few have championed a saddle-shaped universe, but a spherical cosmos makes sense to us Earthlings. Earth is round, as far as are the sun and planets. A spherical universe would let you sail into the cosmos in any direction and end up back where you started, like the Ferdinand Magellan's crew circumnavigating the globe. Einstein called this model an infinite yet unbound universe. But starting in the late 1980s, a series of orbiting observatories built to study the CMB made increasingly precise measurements showing that space has no curvature at all. It's flat to the limits of what astronomers can measure, if it is a sphere. It's a sphere so huge that even our entire observable universe doesn't register any curvature. The universe is flat like an endless sheet of paper, says Mather. According to this, you could continue infinitely far in any direction and the universe would be just the same, more or less. You'd never come to an edge of this flat universe. You'd only find more and more galaxies. That's all well and good with most astronomers. A flat universe agrees with both observation and theory, so the idea now sits at the heart of a modern cosmology. The problem is that unlike a spherical universe, a flat one can be infinite or not. and there's no real way to tell the difference. What could you look for to see whether there is an infinite universe, Trimble says, but nobody quite knows. So instead, astronomers hope an answer can come from theory, a model that would offer indirect proof one way or another. For example, the standard model of physics predicted the existence of numerous particles like the Higgs boson years ago, before they were actually discovered, yet physicists still presumed those particles were real. If you have a good description of everything you have observed so far and predict something is true, then you expect it is, Trimble says. That's how most scientists think about how science works. So I thought that was an interesting little thing. Where is the edge of the universe? So I thought, let's make that a very last article for tonight. All right, you're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. I thank everybody for tuning in for tonight. Even though I wasn't here last week, I'm glad that some of you folks remembered to tune in tonight and have and listening in. And I've been struggling a little bit, so I think I've made it through pretty well. All right, we'll do a quick call in on 3541 kilohertz and see if there's any stations wishing to quickly check in, say hi and bye, and then we'll call it quits for the night, I think. I forgot to mention too, there was an interview with Professor Lisa Harvey Smith with our President Mark Scario this week. If you missed it, it's available on YouTube. Just go to the ASV's website on YouTube, the ASV Tube website, whatever, and you'll see that interview. It went for about 40 minutes, but an interesting little one-to-one discussion with Lisa Harvey Smith and her new book that she's just published too. What I might end up doing is replaying that interview over Melbourne TV repeater in due course. This is VK3 EKH, listening on 3541. Let me turn up the volume. And for any stations wishing to check in.
VK3JR. VK3VIN. VK7JH.
Okay, VK3JR, VK3VIN, g'day Ian, haven't heard you for a while. VK7JAH, anybody else?
VK3BSF.
Okay, it was a VK4W, what was it?
Kilo 4, Whiskey X-Ray, Whiskey WXW.
Roger, VK4 Whiskey, X-Ray Whiskey, and VK3BSF. Any other stations? All right. To the top of the list, g'day Frank, VK3JR, VK3EKH.
VK3EKH, VK3JR. Good evening, Clinton. Special good evening to you, Ian. Good to hear you on these missions again. It's sounding very strong here, very good indeed. I wonder what you're using. It sounds like you got your antenna fixed up, all working well. Very interesting broadcast, Clint. I was very interested in especially in the last article on the possible size of the universe. Who knows, eh? And of course, always the space weather situation I find very, very fascinating and helpful in my listening. Anyway, thanks for doing it, Clint. And there will be missions this evening, perhaps not too long. VK3 EKH, VK3JR.
VK3JR, VK3 EKH, just taking a glass of water, a sip of water from the glass just then. No worries, Frank, and yeah, I kind of deliberately wanted to place that article to the end, but I was kind of trying to time it so that it was a bit before 11 o'clock, but it never works out. Anyway, so but there it is, and I thought it was interesting for sure. Ake on the missions later on. Say good day to Steve for us. All right. Good signal from you, Frank, and I think it's across to Ian. Let's find out what's been going on with Ian there. VK3VIN, VK3EKH.
Yeah, g'day, Clint. G'day, Frank. Frank, I was going to send you an email to let you know I was going to be back on tonight, but yeah, we've had some computer glitches here. Open source programs are wonderful. It lets people contribute to them, but nobody tells anybody else sometimes what's happening, and you can get a whole program messed up totally. And that's what happens with some of the open source programs, as you probably know. 5 and 9 plus 10 for you, Frank. Clint, 5 and 9 plus 30. With a bit of fade occasionally, but yeah, my doublet was not behaving very well. Wouldn't match on 80 metres, and I had significant received signal losses. So that had to come down, and replacing it with an end-fed half wave for 80 metres. So it's 40 metres long, would you believe? Wandered around the yard a bit. So that's been enabled, that's allowed me to get back on. So I'll be interested to get a report from you. Thank you for the broadcast. Gee, it's nice to be able to listen again. And I've been able to communicate with the stations on 80 metres that have been missing from my chat for several months. Yeah, I liked the last article too. And, Jim Lovell, yes, Jim Lovell, 95, so what's that, 2 or 3 years older than Marilyn. What a wonderful contributor to modern science and to faith and to the world. Wikipedia lists him as a space aviator, amongst other things, so that's tremendous, and he lived on, as do his children. So there we go. Thank you for the broadcast, Clint, and it's nice to be back with you. VK3EKH, VK3VIN, over.
Yeah, okay, Ian, VK3VIN, VK3EKH returning, and